Hi, my name is Azril Dahari from Repair Center. Assalamualaikum. Today I will be sharing about re-engineering and fabrication of power plant parts. Our repair center is located in Klang, which is a facility under Technical Services TMB Power Generation Sdn Bhd. Repair Center was established in 1994. We had a series of technical transfer agreement with GE in 1994 for refurbishment of GE stationary components, with Turboker in 2007 for refurbishment of rotating components, and with KC Engineering in 2012 for rebabit of bearing. At Repair Center, we have about 90 full-time staff and 100,000 square feet facility. In terms of general capabilities, we have gas turbine parts repair, bearing remodeling, pump and gearbox refurbishment, reverse engineering and spare part fabrication, hydro and pump parts repair, and power plant solution provider. This is the outline of my presentation today. We'll start with definition and why we do reverse engineering, our experience in reverse engineering and fabrication, and I will also share with about reverse engineering methodology. We'll start with intellectual property right issues, reverse engineering process, re-engineering process, and fabrication process. I'll also talk about our future initiative and some of our experience. Engineering, as we know, started from the idea. Then we do the engineering analysis to come up with the part. Reverse engineering, on the other hand, started with the parts. We do data acquisition and measurement on the part. Then we justify the data using engineering analysis and fabricate a new part. Re-engineering is we taking a step further from the reverse engineering by doing some improvement to the part. So by re-engineering, we'll get a better than the original part. Let's see why people in various industries do reverse engineering and re-engineering. First, there are many equipment that is already obsolete and the OEM no longer exists. The equipment still work fine. In TMB, we have many such equipment in our older plants such as Cameron Highland. So the first reason for reverse engineering is to replace obsolete parts. There are also occasions that OEM need long lead time to deliver parts, but we cannot wait for that long because our plant is down. For example, last year we have a broken ID fan in one of our power plant. The OEM can only deliver replacement part in February 2021. Thus, we had to reverse engineering and fabricate the fan parts to avoid having to endure loss of millions of ringgit. The third reason is to reduce operational costs. While the cost of spare parts are only a few percent of our power generating costs, it's still in hundreds of millions every year. So it only makes sense to save 30 to 50% by doing local fabrication as long as the part quality at par with the original parts. For example, a small pump shaft made from a low alloy steel will cost around 20,000 ringgit if bought from the OEM, but local fabrication will cost less than 10,000 ringgit. The fourth reason is to improve the part, normally because the part keep failing before its service interval and the OEM does not provide satisfactory support. When the part fails before a plant outage, it causes force outage to the whole plant, and this is very expensive, causes hundreds thousands ringgit per day in opportunity loss. We normally improve such parts using a better material, a better design, or application of hard facing coating to reduce wear rate of the part. These are the main reasons why people in the industry do reverse engineering and re-engineering. Our journey in reverse engineering started about 14 years ago after TMB Rimaco signed technology transfer agreement with Turbocare, a third-party space provider in 2007. Unlike technology transfer with OEM, where the OEM will transfer you documents and advisors to localize their processes, technology transfer by independent space provider is without any handing over of documents. They send an advisor and work with us to develop the processes. One of the processes is reverse engineering, where we had to scan used or new blade, develop 3D model and drawings, and work with the dimensional data for our refurbishment process. This experience provides us with confidence level necessary to embark beyond gas turbine parts into other power plant parts. We started with fabrication of burner spools in 2012. This is the first product we use proper reverse engineering as we are using now, which I will explain later. Then, we work on cooling water pump impeller, which we had to make design improvement. This is the first time we have to work with stress analysis software to justify design change. In 2014, we had the opportunity to carry out reverse engineering on hot gas casing, a combustor part, which contained pending patent. So we had to work with intellectual property lawyer on how it's safe to proceed with the work and bypass the claim in the patent to ensure that we do not infringe the OEM patent. This experience provided us with the knowledge, skill, and most importantly, confidence level to work with external customers. We rode on the decline of world oil price and offer our services to oil and gas industries, which are looking for operational cost optimization. We picked pump as our stepping stone as pump is the most common rotating equipment in both power plant and oil and gas industries. Being a gas turbine repair center, we work mainly with welding, grinding, and thermal coating, and less on fitting mechanical parts per se. Thus, we had to equip our personnel with skill on equipment overhaul, roller bearings, shaft, and shaft strengthening. At the same time, we are also working with local foundries for casting of parts to the acceptable level as per standard requirement. In 2020, we had the opportunity to 3D printed impeller. This journey provided repair center with a unique set of skills, and a part development guideline has been approved to be used in TMB Genco in August 2021. This is a freshwater pump impeller. I will use this as a case study to explain on reverse engineering methodology. This pump has a cavitation issue due to low suction pressure. I am at no liberty to share the brand of the pump, but I will call it company F. The part is about 420 kilogram, and the pump is come with 1300,000 kilowatt motor and rotating at 740 RPM. The medium is fresh water, and the impeller material is made from ASTM A216 WCB, which is cast steel. This slide sums up the process flow when we do RE. When we receive inquiry from customer, we need to get some information such as part name, brand and model, and what are their needs. Depending on the part, we'll check the intellectual property right. In Malaysia, intellectual property is administered by Perbadanan Harta Intelek Malaysia, PHIM. We normally check for trademark, patent, copyright, and industrial design in their website, www.myipo.gov.my. The second step is to do data acquisition, which consists of design intent, material, and dimension. The third step is to carry out analysis based on the obtained data. We'll identify design standard and material standards to be used, create 3D model, and if needed, to carry out further 3D computational analysis. The output from this step is 2D manufacturing drawing with tolerance to be used by our fabricator. The fourth step is fabrication. Prior to fabrication process, we have to prepare quality assurance plan that outline detailed activities, methods, acceptance criteria, and responsibilities of every party in the work. If there are many parts spread of several fabrication batches, we normally prepare first articles and check the first article thoroughly. Once the first article has been approved, then the production part can be fabricated. During the fabrication, quality control will be done in accordance to the quality plan. All the quality control check sheet will be compiled as part of final manufacturing data sheet to be submitted to the end user. Now let's see the definition of intellectual property. Right. Trademark, patent, copyright, and industrial design. Trademark is any sign capable of being represented graphically, which is capable of distinguishing goods or services of one undertaking from those of other undertaking. Trademark is governed by Trademark Act 2019. It provides 10 years protection and is renewable. The second is patent. Patent is an exclusive right granted for invention, which is a product or a process that provide in general a new way of doing something or offer a new technical solution to a problem to exclude others from making, using, or selling invention. The keyword here is to exclude others because even though the patent is published, it will prevent others from making the same thing. Patent in Malaysia is governed by Patent Act 1983 and it provides protection for a maximum 20 years. The third one is copyright. Copyright is a protection given to authors, copyright owners, and performers of their copyright work and performance as prescribed under the Copyright Act 1987. It provides protection during the lifetime of the creator and 50 years after the deaths. The fourth one is industrial design. It features shape, configuration, pattern, or ornaments applied to an article by any industrial process, which is the finished article, appeal to the eye and are judged by the eye. It's governed by Industrial Design Act 1996. It provides protection for 5 years and renewable every 5 years up to 25 years. Now, let's see how we use My IPO website to check for intellectual property. First, we check for trademark owned by the OEM. From the result, the OEM has trademarked their name and symbol. So in our document or on the part, we cannot use a trademark to misrepresent the impeller is of the OEM. However, we normally allow us to say the impeller is suitable to be used for the company F pump. Let's do patent check. Let's examine whether the company F has filed for any patent. Based on the search, company F does not file any patent in Malaysia. Now, let's broaden our search and search for pump and impeller. We found 4 files and only 1 granted patent. Now, we have to check what the patent claim. This patent claim the impeller is displaceable in axial direction. Since the impeller from the company F is not displaceable in axial direction, therefore the impeller is not bound by this patent. On the copyright, we have checked that company F does not file for any copyright. Even if there is a copyright on drawings, reverse engineering on 3D parts are not illegal under Copyright Act 1987. There is also no industrial design filed by company F. Based on the intellectual property right analysis, we can say that the impeller can be reverse engineered and fabricated without any legal complication. Please bear in mind that this is only an example with no critical finding. If you find any granted intellectual property, you may want to engage intellectual property law firm to work with you to ensure you will not infringe any intellectual property right of others. Remember in my previous slide, we had to bypass a pending patent in 2014. We did engage a law firm to help us to circumvent the claims in the patent. As we have cleared the IPR check, now let's talk about the second steps, data acquisition. The first step of data acquisition is understanding design intent of the impeller and the pump. We do this by collecting pump manuals and pump specs from customer and interviewed customer on their predicament. From this, we know that this pump is freshwater pump with small amount of chlorine. The pump was not correctly placed, causing not enough upstream pressure. This caused cavitation and pitting on the impeller. As part of data collection, we do 3D scanning and manual measurement to collect dimensional information of the pump and its relative parts. Since we already know the impeller is made from ASTM A216 WCB cast steel, we did not do material check. Otherwise, we'll use SRF to determine chemical composition of the material. For material that is affected by heat treatment, such as low alloy steel, we'll also carry out hardness tests or tensile tests to determine the heat treatment condition of the part from the material standard. Now we get to the third stage of reverse engineering and fabrication processes, engineering analysis. Since we already know the material, we don't have to carry out any detailed analysis on the material, and we focus on the dimension. Based on our scan data, we carry out measurement and decide the tolerances for the fitting area. Then we prepare 3D model and compare 3D model with our scan data. We'll make good and get the as little as possible the deviation between the 3D model and our scan data. Once we have satisfied with our 3D model, then we'll create 2D manufacturing drawing. In this 2D manufacturing drawing, we'll put tolerances for the fitting area so that it can be machined correctly by our fabricator. In normal case, we can start fabrication with 3D model and 2D manufacturing drawing. However, in this case, customer has problem with pitting due to cavitation issues. Therefore, we propose for the material to be upgraded to a harder material to prolong the life of the impeller. We propose the material to be upgraded to CA6NM, a metastatic stainless steel. In this comparison, we can see that the upgraded material has higher strength and harder than the original cast steel. In addition, the material is also slightly lighter. For pump, it's normally a concern if the impeller is heavier by more than 10%, but not a problem when the impeller is lighter. In the case study for the fresh water pump impeller, we do not make any design change. But here I would like to share with you a re-engineering process to make some improvement on the impeller. In this case, a power plant had their cooling water pump impeller broken at the roots of the blades. Based on the stress analysis of the original design, we found it has high stress on the road. Thus, after discussion with Foundry, we decided to add more material to stiffen the road. The stress analysis shows that the stress at the road after the modification has reduced significantly. But adding material caused the impeller to be heavier by 10%, but this is still acceptable to the end user. Once we have done all the engineering analysis, we are ready to move into fabrication processes. But before fabrication can start, we have to prepare a quality assurance plan. In this plan, there are columns for activities, procedures, acceptance criteria, verifying documents, and responsibility. If we have only one piece to fabricate, then we proceed with the production parts. The fabrication process starts with wooden pattern preparation, which will take several weeks. Then the foundry prepare a sun mold using the wooden pattern. The foundry will melt raw material and check with spectrometer to verify chemical composition. Once the chemical composition within a designated range, they will pour the molten metal into the sand mold of the impeller and separate molds for specimens. After cleaning of the casted parts, we'll do machining, NDT, and balancing on the impeller. At the same time, we'll also do tensile tests on separately cast specimens to record the tensile strength of the casting. If there are many parts, we normally prepare a first article. It could be one piece or several pieces. The fabrication process and quality control should be similar to the production, except that we do a destructive testing on the first article. This is an example of fabrication of 24 pieces of ID fan blade. If the part passes the destructive and non-destructive tests, we will freeze the process and proceed with production of the parts. The first article validation is there to ensure that we do not make any mistake which will be repeated to all batches. If there is any mistake, it will cost money to redo all the processes and we wasted a lot of time and resources. I also would like to share two of our future initiatives. The first one is to have product data management software. Currently, we are operating manually, where data is kept in local server and document review is done manually through discussion, email, and WhatsApp. We have faced data loss numerous times due to hard disk failure. In addition, document review is not properly recorded and drawing revision is done manually. In addition, as we also have staff moving out to another department, some critical data is not properly handed over. As we have accumulated about more than 5 years of data, the data has become unmanageable if we keep doing it manually. PDM will provide structured reverse engineering and fabrication workflow and no longer depend on individual. PDM also provides security and safety of our data. In addition, with closer and trackable collaboration, we expect the use of PDM will save time during design analysis and eventually money. After some due diligence and since we are using primarily SolidWorks modeling software, we plan to have SolidWorks PDM by end of this year. This PDM will also act as a basis for our second initiative, Digital Part Library. The idea is, as we have done many reverse engineering and fabrication, some of the parts could be ordered again. The digital library will have all the information needed to fabricate the part within allocated time. We're hoping this initiative will reduce stock holding level in TMB store and ultimately save money for TMB. These are our experience in reverse engineering and fabrication for the last 3 years. As you can see, our experience are varied across various equipment in power and industrial plants. Our customers are not only TMB but also other IPPs and oil and gas companies. I hope With this sharing, we'll be able to learn from each other. There are many aspects in reverse engineering and fabrication that we can improve further, and I'm hoping for your feedback. You can contact me at my email address below or on my mobile number. Thank you. Assalamualaikum.